Hi Moonhackers, welcome to today's code along for Party Puzzle. This year Moonhack is celebrating our 10th anniversary, having a birthday party to celebrate so many wonderful years of coding. This project using Scratch is aimed at more advanced users who understand the blocks, as we do get into some complex coding a bit further down the track. But as always, anyone can join in the code along. Let's get started. From the instruction sheet or from the adult who is working with you, you need to open the Starter project. Here I am logged into my personal account, so I'm going to click on the Remix button. But if you are just coding from the app or from the website, you're going to click on See Inside. Today's creation is a project that is a jigsaw puzzle. We have the image on our screen already. This allows the player to understand exactly what the finished product is going to look like, rather than just be given a bunch of pieces of a puzzle and not know what they're creating. We are actually going to start with the backdrop because we're going to change how it's presented so we can see it as just the background. So for our first one, we're going to click on the backdrops, our stage area over the side here. We have got a page here to be able to place some code that applies just to the backdrop. You will notice that some of the blocks change. We get rid of the motion blocks because they don't apply to the backdrop. We are going to start with the event when the green flag is clicked. Let me shrink that up a bit. And what we want to be able to do is to change the look of the menu. So we're going to come and add in a change. Here we're going to use the ghost effect and we're going to change it by 80. What this will do is make our background look quite see-through, so we can tell that that is the backdrop and we know what we're going to be creating. Now it's time for the puzzle pieces. You'll notice we only have one sprite for this project, but if we click into the costumes, you will see that there are all of the different pieces of the puzzle, each as a sprite. Now, located on here, we have got the piece sitting in its exact position with our center mark being here. This is really important in our code because this means that we're going to overlay these sprites on top of each other. And we're going to jump back into the code to get started. Use an event when our green flag is clicked. And at the very beginning, we need to hide the pieces. So we're going to hide it away. We don't want to be showing them on screen just yet. We're also going to tell our sprite to start with costume number 1. They are numbered from 1 through to 20 for ease of identification, but we want to start with number 1. Our next task is to create what is going to bring all of our sprites onto the stage. Let's add in a repeat loop. We're going to repeat this 20 times. So we have 20 of our different pieces to put up. And the very first thing we're going to do is tell it to go to a random position. To ensure, though, that it sits in the middle of the screen, we're going to give it a bit more of some specific details about where to sit. Let's add in a control of repeat until. Make sure you get the repeat until block, not the repeat one up the top. And our conditions in here is that it is not, let's grab our operator here, not, and from the sensing menu, it's not touching the edge. So we're going to grab our touching block from the top and the drop-down menu, select edge. And if it is touching the edge, we want to continue it going to a random position until it does not have that. Once it has reached that position, we want the sprite to create a clone of itself. So if we scroll down a little bit further, create a clone of myself. Then we will tell the sprite, once it's done that, to switch to the next costume so that the next sprite is the following costume all the way through. And just to add a bit of sound and a bit of pizzazz to our puzzle, sound like something's happening, we're going to start a sound. Now, at the moment, there's no sound here, so let's jump to our sounds tab. You can choose what sound you would like to include, but I'm going to use the one that's called wood tap. Sounds like something dropping onto some wood. So I've got the idea of those puzzles falling onto a table. Now I can add in the sound of wood tap. And that first algorithm there is now complete. At the moment, we're not actually going to see anything happen. We need to tell our clone what to do when it does start as a clone. So let's grab our when I start as a clone hat block. And once it's started as a clone, we do need it to show on the screen. So if you run your code now, you will have those 20 pieces show up onto your screen. Second part of our project is to code the sprite to know how to react when a player is attempting to move those pieces of puzzle around. Now, here's a really important piece of this project for you to understand with Scratch. Right now, as the editor of this, I can pick up a sprite and move it on the screen. This is done because I'm currently in editor mode. However, if I flip so that I'm in full player mode, full screen mode, I can't move them around. This is a screen we need to keep coming back to check what our users will be able to do with our code. If we just keep doing it in this screen, we would assume that a player can move the pieces even though they can't. So let's code it so that they can. I'm going to start with the event when this sprite is clicked. We're going to add in an if-then branching block. Let's drag this across. And we're going to set the condition that if its position is false. To do this, we're going to grab an operator. We're going to grab the equals sign. From our variables, we actually need to create a new variable. I want you to call this variable position. Now, it's really important that you select the dot beside this sprite only. This is a key component of this puzzle. We want the variable of its position for each of the sprites to link to the clone that is created, not have the same for everybody. So really important step there. So now we can drag our variable if the position is equal to false. If that is the case, we want to send our sprite to the front layer. It's going to sit on top. On top, we're going to be able to move and manipulate it. Our next steps in our being able to move the sprite is to control the movement as well as controlling when it gets locked into place because it's actually found its position on the board. So to create two of these, we're actually going to make our own blocks. So jump down to the My Blocks menu and let's click on Make a Block. The first one, we're just going to call Move. Our ability to move our pieces around on the screen. We're also going to create a second block, and this one's going to define how the piece gets locked into position in the puzzle when it's found its home so that it can no longer be moved. So start by adding the text lock into place. The next part of this block is only actually going to be a number. We want to be able to put in a number of pixel distance. So add the input for number or text, and in here we're going to put distance. That's what it's going to represent. And then we're just going to finish with a bit of a label at the end to position. Once you've done that, click on OK. And now we have our two blocks that we have created. Underneath these, we're going to create how that block is controlled and what it does, and then be able to put them into our algorithm here. So we're actually going to do that now. We've got when the sprite is clicked, its position is set to false. It's going to get to the front layer. We're going to be able to move it below this. And then we're going to lock it into place if it is 10 away from its actual position. And this is where those X and Y coordinates are going to come into play. Let's define our move block. Our move block is going to control how we are using these and moving them about the screen. This block is really important because it's acknowledging a difference in coordinates. The difference is going to be that our sprite here, although it's set off to the side, its middle is here. This is our 0, 0 coordinate. On the screen, though, the person is using the coordinate here where the mouse is clicking down. So we need to establish the difference that sits between where the mouse is and this middle coordinate. Let's start by creating two variables, one called X difference and one called Y difference. I'm going to set our X difference first. Make that a bit bigger. Our X difference needs to be the position of the sprite and taking away the position of the mouse. Let's drop in a takeaway operator. From the motion menu, grab your X position, and from the sensing menu, grab your mouse X. We're going to do the same thing for the Y position. Let's grab our variable, adding in that takeaway, and we've got the position of Y, taking away the mouse position of Y. So we're setting that variable as a distance. On our code up here, when the sprite is clicked, so our mouse is held down, we're going to be able to move the sprite. And we want to do that until something happens. So let's add in a repeat until function. We are going to set the conditions that we're going to repeat this until the mouse is not down. And that is going to tell it where to go to. Again, we need an operator because we're looking at the difference. We need the plus operator. I'm going to drop one in both sides right now while I'm in the same menu. So our go-to here is taking this difference that we have recorded and adding on the difference of the mouse. So jump into our variables. Let's drop the X difference here. I'm going to do the Y difference on the other side while I'm in this menu. And back to our sensing with our mouse, X and Y. So the program is continually calculating when I am clicked down on that jigsaw puzzle piece, the difference between that 0 coordinate and where the mouse is. And then when we release it, it's putting it into that position where the X difference is linked to the mouse. A little bit confusing, but it's how it works. Let's go test it on the screen. I can't actually move them yet. Let me go back to my code and double check. We haven't added this step in. Here with the mouse, when the sprite is clicked, if the position is false, then it will allow it to move. I haven't actually set that condition into place yet, so let's do that here. Under when I start as a clone, let's grab our variable, drag it across. We're going to set position to false. So if I run that now, also now I can move my pieces around. Now, the next step is to define that lock into place. So this piece down the bottom here, this is the spot where it needs to go. Even though I've put it in the correct position, I could remove it. I don't want to be able to do that. I want it to lock into place. Let's go and code that. So we want our define lock into place block here. We've got it as part of our algorithm, but we need to actually define exactly what happens to make this one come true. Now this one gets to be a really big algorithm. Big, not in length, but the conditions that we set. We're going to start with an if-then block as our control. And the condition that we set in here is really big. It's lots of operators nested within each other. As with all of our other bits here, it sits around the X and the Y coordinates. So let's drop in an AND operator. X will be in the first side and Y will be on the other side. Sitting within this, what we're going to be looking at is the absolute of the X position and linking it to that number of distance. So what we're saying to it here is if, for example, our sprite down the bottom here, remembering it's working out the difference. So in here, we're just using that middle bit of 0, 0 as the coordinate. What we're trying to get it to read is if the X and the Y are within 10 of that 0, 0 coordinate, it will lock it into place. So for example, if the user had it and its X and Y coordinate were 1, 3, it would lock it into place because it's within 10 of both of those. Because we need our absolute value of that distance to be smaller than the distance we set here, we need to drop a smaller than operator into each side. Then we're going to go to the bottom of the operators and grab this one down here, the absolute value of, and we'll pop one in both the X and the Y coordinates. Well, it's starting to get long now. So first of all, we'll start with the X. We got the absolute value of X position is less than the distance we set. We're going to drag this one down into here. And the absolute value of the Y position is less than the distance we set. Then whatever we put into here is going to take place. And I keep referring to 10 because that is the number value that we put into our block up here. So if the person has got the coordinates to be that super close to 0, 0, but not quite there, we are going to force the block to go to coordinate 0, 0. This will make sure that they will all line up. We are then going to send that block to the back layer. Remember when it started as a clone, it came to the front layer. Now it's going to go to the back because we don't want to really focus on it. We don't want it to be overlapping pieces that haven't been used yet. So we'll send it to the back layer. I'm also going to add in a sound just because I think it's nice to hear that little, woohoo, you've done it. You've popped it into place. So if we are now in place from our variables menu, we now want to set that position to true. Oh, let me put it as true. This is how our algorithm before, when the sprite is clicked, if it is false, we can move it. Now that the position is set to true, a person won't be able to move it. We're also going to, in this project, give them a bit of an indication of how many pieces they have left to go. So let's add a new variable and we're going to call it pieces done. And here we're going to change pieces done by 1. Okay. Let's go to full screen mode and test this out. It's good to test all the time, make sure that we're doing the right thing. I'll start with my very obvious block. Look, it's locked into position and I can no longer move it, which is exactly what I'm looking for. And my pieces done goes up by 1. Now that we've got everything being controlled about how to move the pieces, how to lock them into place so that they're done, we need to settle the conditions about being able to finish the puzzle. Let me go back out on my screen a little bit. We've done lots of pieces of code here. We want to go back to this when the green flag is clicked algorithm. I'm going to add some things into here now that we've started some other pieces. So in here, we are going to create another variable called number of pieces. And at the beginning, before everything happens, we're going to set the number of pieces to 20. So there's 20 pieces in the puzzle. We're going to set that at the very beginning. We also need to set that pieces done to 0. To figure out when the puzzle is completely done, if the number of pieces equaling 20 is going to equal the number of pieces done at 20, then we can have something happen. In our algorithm with when the sprite is clicked, we're going to add that condition into there. So let's grab an if-then control and drop it into that lock into place. We'll pop it underneath that. We want this continually being checked when each sprite is clicked. We'll grab the operator of equals. And we'll jump into our variables. So when the pieces done equals the number of pieces, let's send a broadcast of, we'll make a new one, complete. Okay. So let's code what to do when I get the message of complete. We're going to add in a sound. I don't want the wood tap anymore because my pieces are all in place. So let's add another sound on the sound tab. I'm actually going to choose to play Happy Birthday. Let me select my sound. So now the project should be all complete. Let's go and check the finished product. Oh, actually, before I do, I've just noticed I can see all these variables on my screen. I don't actually want my users to see any of that. I don't want number of pieces. I might not delete it, we'll hide them from the screen. Let's test. Okay, how good of puzzles are you? See how we can see slightly in the background what that image is to be able to help the user put them into place. If you didn't know what the picture was, you would actually find that really difficult to do, particularly because in this puzzle, the pieces are rectangle. They are not, they don't have shapes like others. So satisfying to hear that sound, that clicking in. Now, this last one might be a bit tricky for people to see. Make sure you give your project a name before you save it. Thanks for joining in the Moonhack fun of creating a jigsaw puzzle. So excited that you have joined us today, and I'm hoping that you will share your finished projects back to us here at Moonhack headquarters. We've got lots of other projects for you to join in with this year. You're also welcome to go and visit any of the past Moonhack projects. And celebrating our 10th birthday, we've loved having you. Happy coding, everyone.